Hi friends, this video we are going to see Cayley Hamilton theorem. What is the Cayley Hamilton theorem states? The theorem for any n by n matrix A if P of lambda equal to determinant of A minus lambda I is the characteristic polynomial of the matrix A, then P of A equal to 0. What is the meaning? That is, if you are representing the matrix polynomial using the characteristic polynomial, then given matrix itself is a root. This is this theorem known as the Cayley Hamilton theorem. This theorem known as the Cayley Hamilton theorem. Let's see few examples. So I consider the first example is a simple 2 by 2. So suppose I take A equal to 1, 2, 2, 1. This is the matrix. So what is the characteristic polynomial is? That is P of lambda equal to determinant of A minus lambda I. Correct? So clearly this guy is become lambda square minus 2 lambda plus minus 3. You will get this is the characteristic polynomial. Now I take it. So P of A we are going to find because I am going to verify the Cayley Hamilton theorem. P of A equal to A square minus 2 times A minus 3 times I. So what is the A square? A square is nothing but A times A. This guy become 5, 4, 4, 5. So then P of A, that is apart from that everything we know that, correct. P of A equal to A square. A square is 5, 4, 4, 5 minus 2 times A. A is 1, 2, 2, 1 minus 3 times I. I is a identity matrix 1, 0, 0, 1. So now you compare all the things. 5 minus 2 minus 3 is become 0 will come. Then 4 minus 4 is 0. Here also 0. Here also 0. So that meaning is, so hence thus we verified the Cayley Hamilton theorem. So next is, we using the Cayley Hamilton theorem we can find the inverse of the given non-singular matrix. So let A be a n by n matrix n non-singular matrix we take, okay, because we are going to find the inverse of the given matrix, non-singular matrix. So then what is the characteristic polynomial? Characteristic polynomial p of lambda equal to, suppose it's n by n, so lambda power n, some constant a1 times lambda power n minus 1 plus a2 times lambda power n minus 2 and so on plus an. This is the characteristic polynomial of the given matrix. Because it is a non-singular matrix, clearly that an is not equal to 0. Since that an is here, determinant only will come. Yes, we know that from the property of the characteristic polynomial. We know that an is not equal to 0. That is the key point. From the Cayley Hamilton theorem, we know that p of a equal to 0. So this implies a power n plus a1 times a power n minus 1, a2 times a power n minus 2 and so on, an times I equal to 0. So now you take it as an I minus times a power n plus a1 a power n minus 1 and so on, a n minus 1 times a. You can write this way. Then you take I equal to minus 1 over an. Because an is a not equal to 0, so I can represent. So I have no issue. One more thing, I will take the outside the a also, plus a1 a power n minus 2 and so on, a n minus 1 times I. I can take a is take the outside. Now I multiply A inverse the A inverse by right side, right multiplication. Okay, right. The meaning is we right multiplication of A inverse by both sides. So we get, A inverse equal to minus 1 a power n times a power n minus 1 plus a1 a power n minus 2 and so on, a n minus 1 times I. This is the A inverse of the given matrix. So how to, suppose this is the 2 by 2 matrix, we take it the same matrix we can take A matrix. Now we know that this matrix is non-singular because the determinant value is minus 3. So we can try the same matrix to find the A inverse. We know that how to find the inverse of the matrix. So we see the example. A equal to, we already take the matrix 1 to 2 1. The same matrix I take it. For the simplification, you must understand 1 to 2 1. Okay. So what is the, from the classical adjoint method we can find means that we know that A inverse equal to 1 over determinant of A times adjoint of A. Adjoint of means 1 1 minus 2 minus 2. So this is the A inverse we already know. From the, this is we take from the classical joint method. Now we are using the Cayley Hamilton theorem. So A inverse equal to minus 1 over an. So here we become A 2 times a power 1 plus a1 times I. So minus time will be there. Okay. So now I want to find what is the a2 and a1. So I require the characteristic polynomial. What is the characteristic polynomial is lambda square minus 2 lambda minus 3. So this is the a1, this is a2. So A inverse equal to minus 1 over minus 3 will come, so it's become plus times A. A is 1 to 1 minus 2 times I. I is 1 0 0 1. So you will get it as take 1 over 3 minus 1 plus 2 minus 1. So here there is no minus, here is one minus is there. If you multiply, you will get the same answer. So this is the A inverse of the given matrix. Let's say the same way we can expand to the n is a 3 by 3 matrix. Suppose I take A equal to, so another example for 3 by 3 matrix. A equal to 4, 2, minus 2, minus 5, 3, 2, minus 2, 4, 1. This is the matrix. I take it. So I want to find A inverse. So how I can proceed? Let's restart. Okay. First step, I will write the characteristic polynomial. The characteristic polynomial P of lambda. How we can compute? We already posted here how to find the eigenvalue and eigenvectors. We already explained how to find the characteristic point. So time being, I take directly, that is determinant of A minus lambda I. So this is nothing but you will get it as minus lambda cube. So you take plus lambda cube also no problem, minus plus lambda cube minus 8 lambda square plus 17 lambda minus 10. If you are using the minor coefficient, mean you will get the matrix is like polynomial is like that. The same way, minus lambda cube plus 8 lambda square. So this only will get. So minus the sum of the minus time. So same thing only will get the characteristic polynomial. Next we want to find the A inverse. A inverse formula is 1 over minus 10, that is 1 over an minus times a power n minus 1 plus a1 a power n minus 2 plus a2 a power n minus 3 and so on, a n minus 1 times I. This is the A inverse formula we already shown. So A inverse equal to minus. So what is the A1? A1 is minus 8, A2 is 17, A3 is minus 10. So this is the, so minus times minus 10. So it become plus 1 over 10 time A power 2 plus A1 is minus 8, so A1 is minus 8, A plus A2 is 17 times I. This is the our A inverse. So to find that we require A square, because the given matrix A only they given, so I want to find A square. A square equal to A times A, that is 4, 2, minus 2, minus 5, 3, 2, minus 2, 4, 1 times the same way 4, 2, minus 2, minus 5, 3, 2, minus 4, 2, 4, 1. So you have the scientific calculator, you can directly multiply using your scientific calculator also. So A square equal to, you will get 10, because 4 times 4 16, 16 minus 10 plus 4 is 10, then 6 minus 6 minus 39, 7, 18 minus 30, 12, 30. This is the A square of A square. So now I apply in this formula. So A inverse equal to 1 over 10 times, so you want to write the A square first. A square is 10, 6, minus 6, minus 39, 7, 18, minus 30, 12, 13, minus A times A. A is 4, 2, minus 2, minus 5, 3, 2, minus 2, 4, 1 plus 17 times I. 1, 0, 0, 0, 1, 0, 0, 0, 1. This is our I. Now we have simply, we add it. So what will come? The first come is 10 minus 32 plus 17. So you will get 1 over 10 you kept as it is. So you will get minus 5, then 6, minus 16, so minus 10, because last component is 0. Then last one is minus 6 plus 16, you get plus 10. So 39 minus plus 40, it's become plus 1. 7 minus 24, 24 it's become 0. And then next value is 2 minus 14 minus 20 and 22. So this is the A inverse. Please, if you want to check it, you please verify using the scientific calculator. You can find the A inverse. Please verify it, or using the classical adjoint method also you can find it. So Cayley Hamilton theorem, not only this application. So one other major application this is. So Cayley Hamilton theorem can be used to simplify the calculation of the matrix polynomial. Okay. So that is we are going to discuss. This is one of the most important application in my point of view. The Cayley Hamilton theorem can be used to simplify calculation of matrix polynomial. So okay, how we can? Suppose you take let f of lambda be any polynomial and let p of lambda be the characteristic polynomial of a square matrix A. Okay. So this is the, suppose f of lambda be a any polynomial and p of lambda be a characteristic polynomial. Suppose I want to find what is the p of A. Okay, my aim is, so we write here in the different color. My aim is compute f of A. So what is the, we know that from the algebra we can write f of lambda equal to some quotient of lambda times p of lambda plus r of lambda we can. So this is the quotient of the polynomial, r lambda is the remainder of the polynomial. Suppose now you take f of A equal to q of A times p of A plus r of A. Okay. So the beauty is the p of A is the equal to, suppose 0 n by n matrix, correct? So any 0 matrix multiply the any matrix become 0. So the easiest way is f of A equal to r of A. So f of A degree is m, r of A degree is less than n. That is the beauty. Okay, you no need to compute more than n. Okay, now we see one example how this is most beautiful. So, example. Let A equal to, the same matrix I take, A equal to 1, 2, 2, 1. The characteristic polynomial we evaluate p of lambda is lambda square minus 2 lambda minus 3. Now let f of lambda equal to lambda power 4 minus 7 times lambda cube minus 3 times lambda square plus lambda plus 4. So this is the polynomial. I want to compute f of A. So how I can proceed? So you can both the ways you directly apply. So f of A means what? So we start with the solution. So f of A means a power 4 minus 7 times a power 3 minus 3 times a square plus a plus 4i. This is the f of A. But if you don't need to calculate the things, the reason is you know the Cayley Hamilton theorem. So we can represent f of lambda equal to, some q of lambda times p of lambda plus r of lambda. So now we can do it. So that is the key idea. Now I can do it as, so what is the f of lambda is lambda power 4 minus 7 lambda cube minus 3 lambda square plus lambda plus 4. The quotient is I want to find and r of lambda. What is the p of lambda? P of lambda we know that lambda square minus 2 lambda minus 3. So I want to find. So it's you already studied how to divide the two polynomials. You multiply lambda square both sides, lambda power 4 minus 2 lambda cube minus 3 lambda square. So this become minus plus plus. So you will get it as, this guy will cancel out. This is become minus 5 lambda cube minus 0 lambda square plus lambda. Again you want to multiply minus 5 lambda. So 5 lambda, what you will get? You will get minus 5 lambda cube minus 10 plus 10 lambda square minus plus 15 lambda. You will get the answer is, this guy is plus minus minus. So minus 10 lambda square minus 15 minus 15 lambda. Then minus 10 lambda square plus 20 lambda. So plus 4 will come. Then minus plus 30. So you will get the answer is, so this is plus, it's 14, yes, minus 14 lambda, not, because 15 plus minus 15 plus 1 is 14. So now you will get it as minus 34 lambda minus 26. This is your remainder. So f of lambda equal to, q of lambda is lambda square minus 5 lambda minus 10. Then p of lambda is lambda square minus 2 lambda minus 3 plus minus 34 lambda minus 26. This is our f of lambda. So now I want to compute f of a. F of a, this types become 0 because this is the characteristic polynomial. This one is the my characteristic polynomial. So p of a is always become 0. So simply we can write f of a equal to minus 34 times a minus 26i. Okay. So what is the a? So this implies my f of a equal to minus 34 times a is 1 to 1 minus 26 times 1 0 0 1. So this is minus 34 minus 68 minus 68 minus 34 minus 26 minus 26 0 0 minus 26. So we'll get the answer is, this is 60 minus 60 minus 68 minus 68 minus 60. This is the f of A. You look, this any it's a higher power order also we can find less than order. That is the second 2 order matrix. The 2 by 2 matrix means we simply find the degree power 1 is fine. This is the most advantage of using the Cayley Hamilton theorem. I hope you understand what is the Cayley Hamilton theorem and how to find using the inverse of the matrix using the Cayley Hamilton theorem and how to evaluate the polynomial, matrix polynomial also using the Hamilton. Thank you for watching.